In this video example, we would like to demonstrate a very powerful option of OptiLayer software. It's called stacks, and this feature makes your work more flexible and provide very large possibilities in designing. A stack is a set of thick media with optional coatings at each surface. For example, a set of the substrates and coatings on each or not necessary on each substrate site, and it can be air gaps. And this tool is very convenient for designing complicated optical systems. Each substrate can be parallel, or in this case all reflections are taken into account, or wedged. In this case, reflected light is going away and is not taken into account. We will consider an example: a stack with antireflection coatings at each boundary, operating in the broad spectral range from 400 to 1200 nanometers. The stack consists of 3 substrate B270, has thickness 1 mm, BK7, has thickness 1 mm, and F5 with thickness 2 mm. Between first and second substrates there's an air gap equal to 2 mm, and between second and third substrates there's an air gap with a thickness 3 mm. OptiLayer allows to specify incident medium, in our case it's air, and also exit medium, in our case it will be also air. Let's have a look how OptiLayer will deal with this quite complicated design problem. First of all, we need to specify a new stack without coatings. We create a new stack on the tab on the page of stacks, give a name stack without antireflection, and specify here 5 media, because we have 3 substrates and 2 air gaps between them. The first one is B270 of 1 mm thickness, then air gap of 2 mm thickness, then BK7 substrate 1 mm, then again air gap with 3 mm thickness, and F5 substrate of 2 mm thickness. We can switch to preview window and see the structure of the created stack. Incident medium is air, default value, and exit medium is also air. Let's load this stack. Then we need to observe the reflectance of the stack in Analysis menu, Transmittance and Reflectance window. Here we can see the reflectance of the stack. In this example we have a standard target for antireflection coating. This coating has operating range from 400 to 1200 nanometers. This is quite broadband antireflection coating, and with respect to this target, merit function equal to 22. So, it means that reflectance of the stack without coatings is about 22%. We load now standard layer materials: niobium pentoxide as high-index material and silicon dioxide as low-index material. And now we can specify a stack with coatings on each surface. It's not necessary to specify at each surface, but in our case, with antireflection coatings, we have to specify coatings at each substrate. We copy this stack without coatings and give another name, stack with antireflection coating. Finally, we can specify our stack. We can do it at Edit and Edit mode. There are 2 possibilities in OptiLayer. We can specify identical coatings for each surface, or for some of the surfaces. We can start with the simplest case, when we have the same coating at each substrate. I simply select this 1-layer coating from the database. This is a single layer of 500 nanometers thickness. In this column, in column direction, we can specify the numeration of layers. Forward means that all layers are numbered from the substrate, and reversed means that all layers are numbered from the incident medium. So, it's quite logical to specify here forward and here forward. Then we can switch to preview window and see that we have 6 coatings, 6 1-layer coatings at each surface. These are starting designs for our antireflection coating. Let's load this stack to the memory and analyze its reflectance. We can see here only 1 coating, because all coatings are identical. And we can proceed with needle optimization auto as in the case of standard designs, and very fast we obtain, for example, 14-layer solution or 12-layer solution. And here, in History window, we can see the total number of layers totally for each substrate. Now we can terminate the process. 18 layers is too much, so we would like to reduce the number of layers. For this purpose, we can use thin layer removal algorithm as for conventional designs, and we can specify the thinnest layer, the thickness of the thinnest layer. In this example, it will be 10 nanometers. After that, we obtain 14-layer solution. We can save now our stack the same as conventional design save stack. We can give, for example, the same name, and separately we can save our coding, save coding as, and give a name, for example, antireflection identical. Now we can preview and switch to preview window and observe our stack. And this is spectral performance of our stack. We can try also another possibility of OptiLayer. We can specify different anti-reflection coatings at all surfaces. Again, we go to our stack, open our stack without coatings and specify different starting designs for each surface. They must be formally different, they must have different names, but they can have equal thicknesses. For example, in this case we specify the same one-layer coating of 500 nanometers physical thickness for all surfaces. So formally, these 6 designs are different because they have different names, but in fact they are identical, because they have the same thickness, 500 nanometers. Okay, let's load the starting design starting stack with different anti-reflection coatings at each side. In this case, we can see 6 different coatings in the design bar. And all these coatings will be different and they will be optimized separately. Of course, this algorithm will take a little bit more time to finish calculations, but the whole structure will be optimized simultaneously. Here we can see final design, final stack. We can see the structure of 6 different anti-reflection coatings. Each coating consists of 12 layers. This is our final stack. We can open it in edit mode. We can observe here names of our anti-reflection designs. We can switch to preview window and observe structures of our 12-layer solutions. All solutions are a little bit different, but on the other hand, they are quite close to each other. And, of course, we expected this thing. But this stack option is a very powerful tool of OptiLayer thin film software. And it gives you additional possibilities in designing. And you can save your time when you design such types of optical systems.